So now today we start the new chapter number 2, which is inverse trigo functions. So we discuss about inverse of trigo functions. Now actually in the chapter number 1 we'll see how to get the inverse of any function. So before I start what is the inverse of a trigonometric functions, I'll give some little idea about inverse of any function. So this is from chapter 1. Okay, so you take a function f from, for example, x to y. That means every member of this set is uniquely associated with the members of this. So suppose there is a set x. Here let me take 3 members, for example. There is another set y which has some members. Let's write 6, 7, 8, 9, and I'll give association in this way. So here you can say f of 1 is 6, f of 2 is 7, and f of 3 is 8 here. Now if you look at to this function here, when I take 2 different members from here, the corresponding members are different. 1 is not equals to 2, 6 is not equals to 7. 2 is not equals to 3, 7 is not equals to 8. So different members are having different images. So such a function is called 1 function here. 1 dash 1, 1 function. If I take this function here, like this 2, 3, here I will take some members like this. This is not 1 function, because if I take 1, 2, 3 here, 6, 7, 8 here, then 1 and 2 both are having same images. So this is called many one function, or not 1 function, not 1 function. So 1 function means different members should have different images. That's one thing. Secondly, here in this function, if you find the range here, what's the range of this function f here, which is set of images 6, 7, 8. And what's the codomain? That is y, 6, 7, 8, 9. So this is not same as codomain. You know this is called codomain, this is called domain. So range of the function is not same as the codomain. That is, all members of the codomain are not covered by the function. But if I take this function, look at this, for example. Here I'll take, let's take 2, 3, 4. Here I'll take 6, 7. So like this. Now this is of course not 1 function. This is called many one function. This is not 1 function. Why? Because 2 and 3 both are connected with single member. So this is not a 1 function. But if you look at the range of this function, range, which is 6 and 7, that is same as the codomain. That is equals to codomain. So such a function is called onto function. Onto. So today we have 2 new words. One is 1 function. 1 function means like this. Different members goes to different members. This is not a 1 function. This is not a 1 function. The second one is onto. What do you mean by onto? There should not be any extra member in the codomain. See, codomain has 2 members, 6 and 7. Both are covered by every member. So this is called onto function. This is also not onto, remember, not onto. Why? Because you have an extra member 8 here. If I take one more here, one more example. If I take one more example like this, suppose here I have 1, 2, 4. Here I have, for example, 10, 11 and 12. Suppose 1 goes to 10, 2 goes to 11, 4 goes to 12. So different members goes to different members in the codomain. So it's 1, 1. and there is no extra member in this, so this is onto. So 1 1 and onto function. So a function which is 1 1 and onto, it is sometimes called bijective function. That you will learn in first chapter, bijective function. Bijective function. Bijective function means such function 1 1 and onto. That means both the members are having precisely same number of members. I repeat, different members are connected with different, and there is no extra member in the codomain. Remember, all members of the codomain are covered by the members of the domain. So such a function is called 1 1 and onto both. And function which is 1 1 and onto, it is called bijective function. So now the question is why we did this. So function f from x to y should be 1 1 and onto. That means it should be bijective. Then you can find its inverse. So in that case you can get the inverse of f, which is denoted by this symbol f raised to minus 1. You recall in matrices, matrix A, then its inverse is a raised to minus 1. You know it, right? Even you had one condition, if you recall, every matrix need not have inverse, and inverse exists only when its determinant is non-zero. So same way here, every function need not have inverse. Its inverse exists only when it is 1 1 and onto. And inverse will be a function from y to x. So if f is a function from x to y, then its inverse will be a function from y to x, reverse. And here if you recall, in matrices, A into its inverse equals to identity, and A inverse into A is also identity. So same way here, when I compose them, this you might have studied in 11th or in first chapter, you'll learn f O f inverse gives you identity function, and f inverse O f also gives you identity. This is identity on y, this is identity on x. Okay. This is the main concept of inverse of a function from chapter number 1. I'll again recap this much. A function from domain to codomain should be 1 1 and onto. This is called bijective. Then and then you can find the inverse of a function. Inverse means raised to minus 1. F raised to minus 1. This is read as f inverse. F inverse will be a function from y to x if f is from x to y. And if you compose these two, here this is operation. In matrices the operation was multiplication. So when I compose function at its inverse, you will get identity. This we will learn later on in detail. And if I do reverse, again you will get identity. So with this concept, we will go to inverse of trigo functions. You recall, if I take a function, for example, like I'll write sine function. It's a function from R to R, basically real numbers to real numbers. You know what is sine 0? It is 0. You know what is sine pi, which is also 0, and so on. What's the meaning of this? At 0 and at pi, value of the sine function is same, which is 0. So you can say that this is many one or not 1 1, or not 1 1 function. Not 1 1 function. So you cannot find the inverse. Even what's the range of the sine function? Range of the sine function, you know, close interval minus 1 to 1. Is it same as codomain? No, it is not equals to R, which is codomain. So therefore, sine function, sine is not onto, remember. So you cannot get directly inverse of this function from R to R. So we need to change the domain to make it 1 1. So we change the domain. We change here domain to make it 1 1. Number 1. And we change the codomain to make it onto. Change the codomain to make it onto. So this much we'll do first to find the inverse of each trigo functions. What we do? Our next point is we change the domain of each trigo function. We do this much for each trigo functions. For each trigo function. Trigo function. Why we change the domain of each trigo function? To make it 1, 1. Why we change the codomain of each trigo function? To make it onto. Why we do this? Why we change the domain and codomain? We want to convert into 1, 1 and onto function. Why we want to convert into 1, 1 and onto? Because we need the inverse of each trigo functions. Why we need this? To find inverse of trigo function. To find the inverse, remember. We must have 1, 1 and onto function. Like as I explained here, sine from r to r is not 1, 1. Even you can add one more here. Sine 2 pi is also 0. So this is not 1, 1 function. At 0, at pi, at 2 pi, like this. If I take 0 here, if I take pi here, if I take 2 pi here, all these are connected with 0 only for sine function. So this is not 1, 1 function. It is sometimes called many 1 function. So this will not do for inverse. Even range, you know, -1 to 1 from 11th standard, which is not same as codomain. So it's not onto also. So to convert each of the trigo function into 1, 1 and onto, we need to change the domain and codomain. And then all the trigonometric functions will be 1, 1 and onto, and hence we get the inverse of each trigo function. So that's our next point. This is just introductory how to get the inverse of a trigo functions. Now next one is actual beginning of this chapter. I just wanted to clear why we are going to change the domain and codomain in the each trigonometric function. I repeat, just to make them 1, 1 and onto. Why we are converting into 1, 1 and onto? Because we want the inverse of each trigo function. Okay, so now we come to main point of this chapter, which is about inverse trigo functions. So here we write trigo functions which are 1, 1 and onto. So the first one, I'll write sine function. As I mentioned, we change the domain to make it 1, 1. So here domain is minus pi by 2 to pi by 2. Right? It has proof why domain is this. 2, we make it on 2. So we need to keep the range equals to codomain. So now we are changing the function here from r to r. Now close interval minus pi by 2 to close interval -1 to 1. I'll again repeat why we have changed the domain to make it 1, 1. Why we have changed the codomain to make it on 2. Right? Now it has proof why domain is this minus pi by 2 to pi by 2. This is sometimes called principal, main branch or principal branch. Why we have changed the codomain? Which is obvious, because if you want to make it onto, range equals to codomain you need to place. So once we take from this to this, it has inverse. So here I'll write the inverse. So here inverse trigo function. So sine inverse will be a function from, if this is from x to y, it is from y to x. So -1 to 1 to close interval minus pi by 2 to pi by 2. And what is definition? Definition is this: whenever y is equal to sine x, if and only if we interchange x and y. So x equals to sine inverse y. This is the definition. I'll discuss with detailed examples what's the meaning of this, but this way we define. We have interchange x and y. Here y is expressed in terms of x, here x is expressed in terms of y. Here you make the x as a subject of the expression. This is read as sine inverse y, remember. Second function, cosine function. There again we change the domain and codomain. Codomain should be same as the range. For these two functions, you know that this is range. And domain is chosen as 0 to pi, that is first two quadrants. This two quadrant, first two, 0 to pi. Here domain is minus pi by 2 here, pi by 2 here, first and fourth quadrant. You know this is minus pi by 2, this is pi by 2. So cos inverse will be a function from where to where? -1 to 1 to 0 to pi. And here definition is y is equal to cos x if and only if x equals to cos inverse y. This is the definition. Same definition for all inverse trigo functions is same. Third function, which is tan function. So if you recall, range of the tan function is R. So codomain is all real numbers. And here we take the open interval minus pi by 2 to pi by 2. It is same as the domain of sine function, but you know tan pi by 2 is undefined. So we have eliminated pi by 2. So we have kept open interval. Here it is closed. At minus pi by 2 tan again undefined. So यहाँ पे open interval minus pi by 2. 2R. Why R? Because range is R, you know. So then tan inverse is a function from all real numbers to minus pi by 2 to pi by 2. Then what is the definition? Y is equal to tan x if and only if x equals to tan inverse y. Same way for cot function. Cot is a function where codomain is all real numbers because range is R, you know. So when you take R here, it becomes on 2. And domain is same as cos function but open interval 0 to pi. Why open interval? Because at pi cot is undefined, at 0 is cot undefined. So it is just from this function open interval 0 to pi. There we have close interval 0 to pi. Now cot inverse will be a function from all real numbers to open interval 0 to pi. Y is equal to cot x if and only if x equals to cot inverse y. Definition is same everywhere. Fifth one, which is Cossack function. So range, if you recall, it is R minus open interval minus 1 to 1, you know. So it becomes on 2. What's the domain? Domain is same as sine function. So minus pi by 2 to pi by 2. Now there is a number between these two, which is 0. And at 0, Cossack is undefined. So we drop 0 from this. So Cossack inverse is a function from R minus open interval minus 1 to minus pi by 2 to pi by 2 minus 0. And what's the definition? Y is equal to Cossack inverse x, Cossack x if and only if x equals to Cossack inverse y. This is the definition. I repeat how I have chosen the domain. Domain is just same as the domain of sine function, which is minus pi by 2 to pi by 2. Why we eliminated 0 here? Because cosec 0 is not defined, because cosec 0 is 1 upon sine 0, which is undefined. That's why we have dropped that. And last function finally, which is sec function. Now you must have realized it just comes from the cos function only. So domain is 0 to pi. Now again at pi by 2, this is undefined. So here we write minus pi by 2 because sec pi by 2 is undefined. To r minus open interval minus 1 to 1. And here cosec inverse will be a function from r minus open interval minus 1 to 1 to close interval 0 to pi minus pi by 2. And definition, y is equal to sec x if and only if x equals to sec inverse y. So these are the main domain and codomain of all trigo and inverse trigo functions. You need to remember mainly domain of sine and cos. Sine close interval minus pi by 2 to pi by 2. Tan open interval minus pi by 2 to pi by 2. This is same as sine, just 0 is eliminated. Cos close interval 0 to pi. Open interval 0 to pi. Why open interval? But at 0 and pi cot is undefined, that's why. And sec same 0 to pi, but pi by 2 is eliminated. Why pi by 2 is eliminated? Because at pi by 2 sec is undefined. And definition of each inverse trigo function is similar. When your y is equal to sine x, we write x equals to sine inverse y. So it's like this. For example, here if I write, you know sine pi by 2, that is 1. So from this we can write sine inverse 1 is pi by 2. It's a reverse thinking, remember. Sine pi by 2 is 1, so sine inverse 1 is pi by 2. That way we understand. Here inverse does not mean this, remember. Inverse does not mean 1 upon sine x, 1 upon sine, remember. This is not correct. Inverse does not mean reciprocal here. It means the way we explained here. So, like you recall, cos pi by 2, 0. So from this we can say cos inverse 0 is pi by 2. Suppose I want to get what is tan inverse 1. So you find for what value of the theta, tan theta become 1. So tan pi by 4 is 1. So you can say tan inverse 1 is pi by 4. Suppose we want sine inverse 1 by 2, for example. So question is, for what value of the theta sine becomes 1? Sine, pi by 6 is 1 by 2. So here it is pi by 6. Because sine pi by 6 is 1 by 2. One more, fourth one. Suppose we want tan inverse 0. So for what value of the theta, tan theta becomes 0. So tan 0 is 0. So tan inverse 0 is 0. One more if I write here. Fifth one. Tan pi by 3, that is root 3. So you can say that tan inverse root 3 is pi by 3. So this way we can find the values of inverse trigo functions. Now secondly, most important remark is here. If I have here tan inverse 1, so I can write tan inverse. Now instead of 1 I can write pi by 4. Tan pi by 4, sorry. So this 2 will get cancelled, inverse and its function. So you will get the pi by 4. That's what I wrote here directly. So what I'm trying to tell you is here, this is called basically composition operation. This is not into. Tan inverse of 10 will get cancelled and it will get pi by 4. So this is always true. Sine inverse of sine theta gives you theta. So composition of function and its inverse gives you that value. Even if I do reverse, sine of sine inverse x, that is again this 2 will get cancelled, you will get x, remember. Your theta should come from the domain of sine function. What's the domain of sine function for which it is 1, 1 and on 2? That is minus pi by 2 to pi by 2. Here x will come from the domain of sine inverse function. So what is domain of sine inverse function? You just recall that earlier point. So x comes from minus 1 to 1. This is true for all inverse trigo function. If I have cos inverse of cos theta, that gives you theta. So inverse and function will get cancelled. You are getting this, which is actually identity. So here theta will come from the domain of cos function. What is that? It is 0 to pi, for which it is 1, 1 and on 2. If I write reverse, cos of cos inverse x, again function and its inverse will get cancelled. So you'll get just x. And what about x? X will come from minus 1 to 1. Similarly, if I write even tan inverse of tan theta, again it will be theta. So that inverse and the function will get cancelled, and theta will be from where to where? Domain of tan function, which is open interval minus pi by 2 to pi by 2. If I do reverse, tan of tan inverse x, so again this 2 will get cancelled, you are left with x, and x will come from the domain of tan inverse, which is all real, and so on for each trigo functions. For example, sec inverse of sec theta gives you sec theta only, and so on. This is always true. So in general, what is all in all, this says that composition of function and its inverse gives you that number only, which is identity. This is not into, remember, this is read as of, so we write inside the bracket. Sine inverse of sine of sine inverse, cos inverse of cos, and so on. So this function and its inverse will get cancelled and you will get just identity numbers. That's the second important thing here. So let's go to first exercise just based on what we did so far. So first question is, you are asked to find sine inverse of minus 1 by 2. You can think directly also. Find the theta for which, this is a question indirectly. Find the theta for which sine theta becomes minus 1 by 2. So you know it is minus pi by 6. Why this? The reason is sine minus pi by 6 equals to minus 1 by 2. So that's why we have this. Now question is, why minus pi by 6? That's the question. Remember, whenever you find this should come from that appropriate domain. That is which domain? Minus pi by 2 to pi by 2. You may have some another theta for which sine theta minus 1 by 2, but that appropriate value should come from these only. Or you can do alternatively like these also. Sine inverse of, instead of minus 1 by 2, you can write sine minus pi by 6. So this 2 will get cancelled as I explained. So you'll get the minus pi by 6. Second question. Cos inverse of root 3 by 2. So question is, find the theta for which cos theta becomes root 3 by 2. So here you know appropriate theta is pi by 6. So we have cos, your value is pi by 6. Reason, you can write this if you want. Cos pi by 6 is root 3 by 2. Third question. Cosec inverse 2. So the question is here, find the theta for which cosec theta becomes 2. So which you know again pi by 6. Why? Because you know cosec pi by 6 which is 2. So therefore cosec inverse 2 is pi by 6. Fourth question. Tan inverse of minus root 3. So the question is, find the theta for which tan theta becomes minus root 3. So it is obviously minus pi by 3 because you know tan minus pi by 3, tan being odd function, minus tan pi by 3, which is, this is root 3, so minus root 3. That's why we have this, remember. So here fifth question is cos inverse minus 1 by 2. The question is, find the theta for which cos theta becomes minus 1 by 2. So here it will be 2 pi by 3. Why? Because if you recall, what is cos 2 pi by 3? That is cos pi minus pi by 3. Which quadrant? Second quadrant. So cos negative. So minus cos pi by 3. What is cos pi by 3? 1 by 2. So we'll get the minus 1 by 2. That's why we have cos inverse minus 1 by 2 equals to 2 pi by 3. Sixth question. Tan inverse of, again sorry, remember this 2 pi by 3 should come from the domain of that cos inverse function for which it is 1, 1 and on 2. So it should come from this domain only, 0 to pi. Any other value will not do, remember. Now come to tan inverse minus 1. So which is quite obvious because you know tan minus pi by 4 is minus 1. That you know. So this answer will be minus pi by 4. Next, for example, I'll go to 10th question here. That was cosec inverse minus root 2. So the question is, you find the theta for which cosec theta becomes minus root 2. So it would be here. So here it would be obviously minus pi by 4 because you know cosec minus pi by 4 is minus cosec pi by 4 because it's an odd function. So this is minus root 2. Okay. So this is just beginning.